All right, so in this problem, what we want to do is we want to basically multiply these two values together. And the way to do that is, you may have heard it called FOIL, or it's double distribution. But basically, I want to take this term and multiply it by both of those, and then do the same thing with the negative 8. So 2x times x, that's my first one. That's 2x squared. Now I'm going to take that 2x and multiply by the negative 2. That'll be negative 4x. So I do the same thing with the 8. Negative 8. Remember, it is a negative 8 right there, so watch out. So I got negative 8 times x is negative 8x, and negative 8 times negative 2 is a positive 16. So at this point, what I want to do is I want to combine like terms. I've got a negative 4x and a negative 8x. Put those together, and that should be negative 12x. So this is my final solution. Cool. I'll leave the other three for you guys to do as practice. The answers are posted, right? So you can check to see how you did. Now the reverse of foiling, or that double distribution, that multiplication thing, is a thing called factoring. So problem 5 is where we begin our factoring. So 5, I've got r squared minus 13r plus 42. So in this problem, what I want to do is I want to say, okay, I need numbers that multiply to this value. So they need to multiply to 42, and they need to add up to negative 13. And I just go through my checklist of numbers that make that happen. 42 is 7 times 6, I know that. 42 is also 42 times 1, it's 2 times 24. You'll notice that all of these, though, add up to positive numbers. Like 26, 43, and 13. I want them to add up to a negative number. So to make that happen, I've got to know a little bit something about negatives too. If I multiply negative 7 times a negative 6, I also get a positive 42. But when I add negative 7 and negative 6 together, I get a negative 13. So for those reasons, negative 7 and negative 6 are my solutions. So I get r minus 7, r minus 6. Now remember, the reason why I want numbers that multiply to 42 is if I was to FOIL this back out, I would do, so this is my final solution, right? But you can always check yourself. R times r squared. R times negative 6, negative 6r, negative 7r, and negative 7 times negative 6 is a positive 42. So watch what I did. I took those two numbers, I multiplied them together. See, they have to multiply to 42, and they do. And when I add those two numbers together, they turn into a negative 13r, which is exactly what I want to have happen. It needs to add up to a negative 13. So you can always check yourself by foiling it back out. But once you get to this step right here, you successfully factored it and are good to go. So 6 and 7 kind of follow that form, but then things kind of go a little bit crazy on problem 8. Let's change this to number 8. I've got 7v squared plus 11v minus 6. Whenever you see a value in front of, that's called like the a value, like if it's 8x squared or 2x squared or 2v squared or whatever, that a value is not 1. It's going to make our lives a little bit more difficult. So instead, half of it doesn't change, right? The half that doesn't change is I still want numbers that add up to 11. So the first change is, if I was just doing this regular, I would need numbers that multiply to negative 6. Well, that's not really the case if I have a number in front of v squared. I have to do numbers that multiply to a times c. So that's negative 42. So I have to look through the numbers that make this happen. You know, negative 1 and a positive 42 don't do it. Those add up to 41, so that's no good. What about negative 3 and 14 though? They absolutely do that, right? So these are the numbers I want. Okay, so here comes the second key difference when the a value is not 1. I'd be done if I didn't have a term in front of here, I would just do this. I just do v minus 3 and v plus 14. But you can see that that's not going to get us anywhere near the answer. If I was to FOIL this thing back out, I'd get v times v, which would be just v squared, not 7v squared. And my last term is negative 3 times negative 14. That would give me negative 42, which doesn't multiply to negative 6. So I'm almost all the way there. The key strategy on this is when you have an a value in front of this v squared, you have to put it in both spots like that. So I have 7v squared, 7v minus 3 times 7v plus 14. Still, I've overshot my answer. 7v, if I was to FOIL this thing out, I would not get my original, right? What I need to do now is reduce. Both of these are divisible by 7, so I'm going to divide both of them by 7. And 7 and 3, they're fully reduced, so they just stay like that. And this becomes v plus 2. So I basically am just reducing there. Now I've got my final solution. If you were to FOIL this out, I get 7v times v is 7v squared. 7v times 2 is 14v. Minus 3 times v is negative 3v. And negative 3 times 2 is negative 6. I would combine like terms, and I get 11v minus 6. So we're all good there. But those are the keys. The key difference is you have to multiply to something totally different. You got to remember that whatever number is in front of here, you put in both of those, and then you got to remember this key step where you divide out, and then just try to make the biggest mess of the paper as you can. Okay. So flipping to the back, we've got some quadratic formula ones now. After like 19 minutes of erasing. So quadratic formula problems. So now what I want to do is I'm solving this thing. I'm gonna do 9. Let's see here. So it's 5m squared minus 7m plus 2 is equal to 0. So to solve this, the quadratic formula is negative b plus and minus the square root of b squared minus 4 times a times c all over 2a. Now the a, b, and c's in this problem are the a value is 5, the b value is negative 7, and the c value is 2. If this thing wasn't equal to 0, I'd have to get it equal to 0 first. So let's say that this problem was 10 right there. What I'd have to do first is subtract 10 from both sides to make this equal to 0. And 2 minus 10 would get me negative 8. So now my c value would be negative 8, right? That's not what it is in this problem. So I'll leave it like that. But just be aware, so like number 10, it's equal to 18. You're going to need to subtract away that 18 from both sides before you can go. The quadratic formula can only find zeros, so you want to see where it's equal to 0. Otherwise, you're kind of done for. Okay, so let's take a look. I'm going to just plug these things in. It's the opposite of b, and b is negative 7. So the opposite of negative 7 is a positive 7. Plus or minus b squared is negative 7 squared. Minus 4 times a times c. A is 5, c is 2. Divided by 2a, a is 5. So I just put in all of those things. Now there's a couple of easy spots for me to do some simplification. The bottom, 2 times 5. Later, you're 10. Negative 7 squared is negative 7 times negative 7, which is a positive 49. And 4 times 5 is 20, times 2 is 40. So that 4ac bit is just 40. So now I keep going, and I have 49 minus 40, which is 9. And I take the square root of 9, which is 3. And so I take 7 plus 3, which will get me, so now I get down to this point where I have this sign to deal with. I have a plus and a minus sign. So I have the I'm going to have two solutions to this, like all quadratic things. Because quadratics are parabolas, they'll have two solutions a lot of the times. So that's what this plus or minus, instead of doing the entire problem twice, with once with an addition sign there and once with a subtraction sign, we save ourselves a lot of work with that plus and minus sign. I know it looks a little bit confusing, but it's really a big convenience for us. So I do them one at a time. I have 7 plus 3 divided by 10 as my first solution. And that's not so bad. That's 10 divided by 10, which is 1. So 1 is my first solution. I know that's right by where my head is. My second solution is 7 minus 3 over 10, which is 4 over 10. Which, I mean, you could reduce to 2/5, or if you're a decimal kid and want to do 0.4, that's my second solution. So those are the two solutions for the quadratic formula. The key is just to be really careful, putting it all in there and not losing any subtraction signs. Okay, so let's go on to one of them that's solving by factoring. So 11, I've got x squared minus 10x plus 21 is equal to 0. So solving by factoring, obviously, it kind of gives us a big hint. We need to factor first. So I need numbers that multiply to 21 that add up to negative 10. So the way to achieve that, I know 7 times 3 is 21, and that adds up to positive 10. Well, that's pretty close. If both of them were negative, I'd have a negative times a negative, which would get me a positive 21. And negative 7 plus negative 3 would get me a negative 10. So those are my two values. So when I factor this thing, it's x minus 7, x minus 3. So now I'll get my two, I have that in factored form. Now, the whole idea behind this is if I have two numbers that multiply together that equals 0, one of them has to be 0. Like if I told you that this is a 9 and the other number we don't know and it multiplies together equals 0, that number has to be 0, right? Well, it's the same thing here. I've got two values that are multiplied together to equal 0. So there's two different ways that that can happen. Either the first thing is 0, so either x minus 7 is equal to 0, or x minus 3 is equal to 0. So what's nice is now I've got two very, very simple equations. What number minus 7 is equal to 0? I'm going to add 7 to both sides, and I get x equals 7. Add 3 to both sides, and I get x equals 3. And those are my two solutions. Okay. So I'll leave 12 for you to solve, and I'm going to do 13 for you. So 13, they ask me to come up with an equation that has a y-intercept at 0, 6, and I want it to open down. So if I just have an equation, all parabolas we basically write like this, where I have an a, x squared, b, x plus c. Just kind of the same way we do have y equals mx plus b. That m stands for something, it stands for the slope, and the c, and the b stands for the y-intercept. Well, with parabolas, we just use a, b, and c because there's like 3 values it could be. Like we have like y equals 3x squared plus 5x plus 7. The 7 is the c value, the 5 is the b value, and the 3 is the a value. So this problem, we want a y-intercept at 6. So that's going to force us to have our c value be 6. The other thing that they tell us is it has to open down. Opening up or down is controlled by the a value. So I just need my a value to be negative. So if I had like -3, that would work. And the b value controls where it is left and right. So I could put anything in there and it wouldn't affect it. That would just shift it one way or another. So this is actually my final solution for that. There's an infinite number of answers. You just need to have a y-intercept of 6 and a positive negative a value. If I look at number 14 here, I have y equals 5x squared minus 9. What they want me to do in this problem is they want me to change the y-intercept so it goes to -10. Okay, so if I want to make that change, that's no problem. I just, instead of having a y-intercept at -9, I'm just going to change that to having a y-intercept at -10. And then they want me to stretch that thing more vertically to make it skinnier. So if it was like this, now I want it to open up even more narrower. Or another way to think about that is it grows quicker, right? So the faster parabola grows, the bigger the a value. So if this is 1x squared, this is 2x squared, 3x squared, 4x squared, 5x squared, like that. So if I wanted to grow faster, I just have to increase that number. And if I wanted to make it wider, I would just need to decrease that number. So this is a good spot to find myself at for a solution. Same thing, if you had 17x squared or 170x squared, all of those would be skinnier. Okay, so 15 and 16, we're trying to find the parabola. No, we're not trying to find the parabola, we're given the parabola. We're trying to find the vertex and the axis of symmetry. And they are really connected problems, right? So I have y equals -3x squared plus 60x minus 1. So the formula for axis of symmetry is -b over 2a. That's how I find my axis of symmetry. So my b value is 60, so I take that and I say, okay, so that's -60 over double what a is. And a is -3. So that's -60 over -6. So my axis of symmetry is at x equals 10. So every parabola that we have, the vertex is going to be on the axis of symmetry. I kind of already know a little bit of something what this one looks like. I know that this parabola opens down. It has a y-intercept at -1, and it has an axis of symmetry at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. Right? And it opens down, so it's going to look like that. So now I need to find the vertex, which is the top point. Vertexes always occur at the axis of symmetry. So when they tell me that x equals 10, I need to plug that in to find the vertex. So I'm going to take 10 and I'm going to plug it in for x. So I get y equals -3 times 100 plus 600 minus 1. So that's -300 plus 600 minus 1. So 299. So at my axis of symmetry, my parabola has a height of 299. So the way that we're going to want to write it as a point, so it's 10 comma 299. And that'll be my solution. Now just imagine I wrote that 299 actually where you guys could see it, right? And that'll be our final solution. Okay.